Everyone, we are going to talk about recursion in this lecture. Now, recursion is one of the most important topics in programming. So, what is recursion? Why do we need to talk about recursion, and what is it used for? Recursion is a programming technique or tool in which a function calls itself. Normally, we have a function calling other functions, but in some situations, we may have a function calling itself. But unless we make some changes, this may lead us to infinite calling, because if you keep calling a function calling itself, it's going to keep going for a long time until you run out of memory and may freeze your computer. So you need to have what we call a base case, basically a stop condition that make that recursive function or call stops. So we'll talk about how it works. The function that calls itself is called a recursive function. And as we mentioned, the recursive function must have a base case or stop condition. Recursive calls will continue until the stop condition is met, or base case. So I'll show you like an example where we can use recursion. So this is an example of recursive function, because the function is about creating or drawing a triangle or square. And then when you keep calling itself, so the program keeps drawing um, that shape, whatever it is, square or triangle, with different value until it stops somewhere. Maybe you start from 20 and then you stop when the side is 1, for example. So you have to have some kind of base case for that function to come to an end. Okay. So let's see basically the algorithm. So we have the function, and then we have certain statements. You may have more than one statement. And then as long as it is true, you're going to go back and then call the function again. So it's going to be done continuously until you get to the base case. So the base case is a situation that make the program stop. So we're going to have an example about that. So this is another picture that shows how the recursive function works. Now let's switch to Visual Studio and then see how it can be implemented. So let's say, for example, we have a function called print. Make it void print. So I'm going to print, and then it takes a number. Let's say n. So I'm going to say, for example, if, and then this is the base case. Without this base case, it's going to keep going forever, because if I did something like this, say out, for example, n, so that means I printed n, and then I called the method itself, but without changing the value. What's going to happen? It's going to keep printing. Let's say I call the function print, let's say 8. So it's going to keep printing 8, because it's going to print 8 and then go back to print 8, and then print 8, and then go back and call the function again. So it's going to stay there like that forever until, as I said, your computer freezes or run out of memory. Okay? But what we can do is make it stop. So it's going to print a certain number. So let's say n, and then I'm going to add a condition. So I'm going to say, for example, if n is higher than 1, so I can print and then go there. So that's going to print n, whatever it is, and then let's say I'm going to put -1. So as long as the number is higher than 1, it's going to be printed. Once it goes less than 1, which is 0, it will stop automatically. So here, if I call the function print 8, it's going to check, is 8 higher than 1? Yes. So you're going to print 8, and then you call the function, but with different value, which is 7. 7 high. So this is pretty much like the loop. It's just like an alternative to the loop. Okay, it has of course advantages and disadvantages. The main advantage is sometimes when we face complex, very complicated problems, sometimes the recursion may seem to be the best option because it's going to break it down into small, simple programs or tasks. So this will be printing 8765432 1. Is one higher than one? No. So let's run the program and see. So we're going to get from 8 all the way to 2. See that? 8765432 1. Okay. Now I can do it in a different way. What about if I said if it is less than 6 or equal, print n, but this time I want to add 1. Now let's say, for example, I'm going to start from 1, print 1. Is 1 less or equal than 6? Yes, print 1 and then call the function with the value 2. Is 2 less or equal than? Yes. And so you're going to keep going until you get to 6. And then once you get to 7, that's the base case, it will stop running. So you can see here, that's going to print all the numbers from 1 to 6. So this is pretty much how the recursion works. Now you can do the same thing if you want to print. I'm sorry, if you want to add numbers. So let's say here, for example, I want to add values. So I'm going to have a function that returns the sum of certain values, but not using the loop. I'm going to use a recursive function instead. I'm going to call it sum. So it takes a value, let's say n, and I'm going to say if n equals 1, for example, return 1. Or I can put if n, this is my base case, or I'm going to say if n equals 0, return 0. That means keep adding until you get to 0 or 1. Now else, so I'm going to return the number, whatever it is, plus, and then I'm going to call the function again. Sum, let's say, if I want to keep going down, I'm going to put n minus 1, for example. So if I call the function, let me just comment this one out so we can focus only on this function sum. So if I call the function sum, let's say with value 6, now what's going to happen? I'm going to check, is 6 equals to 1? No. So I'm not going to stop. This is the base case. And then I'm going to put return 6. So I'm going to add 6 to, then call the function again with sum 5. So 5, is it equal to 1? No. So I'm going to put plus. So I already have 6 plus 5, and then call the function again with sum 4. And then plus 4, sum 3. Plus 3, sum 2. So you're going to keep going. So basically what you are doing, you are adding all these numbers. So you're going to get 6 plus 5 plus 4 plus 3 plus 2 plus 1. 1 is the base case. So if n equals 1, return 1 and add it to the rest. So if I add them up, you're going to get all the numbers. You can add up all the numbers from 1 to 6, which happens to be 21. 21. So as you can see, like we can use the function for a variety of, in a variety of ways. Okay, I can do it with multiplication too. I can say, okay, say product. So I'm going to say, for example, maybe the same thing. If n equals 1, return 1, else return, and then I'm going to multiply this sign. Instead of adding, I can multiply. So return, let's say n multiply by prod n minus 1. So if I call the function prod, okay, let me just put end of line here. So if I put prod, let's say number 4, so what do we think I'm going to get? I'm going to get 4. Is 4 equals to 1? No. So it's going to be 4 multiply by prod 3. Is 3 equals to 1? No. So you multiply now 4 times 3 prod n minus 1, which is 2, and so on. So you're going to end up multiplying 4 times 3 times 2 until you get to the base case, which is 1, and then you multiply by 1. If you run the program, so what is 4 times 3? That's 12 times 2, 24. So we should get 24, as you can see right here. Okay? So this is basically how recursion works. Now let's do something. Okay? Let's use the multiplication, but without multiplying, like without using basically the multiplication table that we memorized. Okay? So let's say, for example, I want to multiply, let's say, multiply 5 times 4, for example. That's 20, right? But I don't want to do it like that, multiply, which is the same thing as 5 plus 5 plus 5, 4 times, right? Because that's basically what multiplication is. You keep adding the same number, 5, 4 times. Once you finish 4 times, you stop. So let's use a recursion for this. So we're going to have function called multiply. Then we have two numbers, 5 and 4, so that's A and B. So I'm going to add 5. So I'm going to use the second number B as a counter, because that tells me how many times I'm going to keep adding A, right? So I'm going to say if B is 4, I'm going to say 4, 3, 2, 1. That means once you get to 1, stop. Okay? So I'm going to say if B equals to 1, or let's say equals to 0, means that's the end, return 0. That means stop, basically. Else, you are going to keep adding A. So return A, because I'm adding A, which is 5, 5, 5, 5. So I'm going to add A plus, and then call the function again, multiply, but I'm going to subtract 1 from B. Remember, I'm using B as my counter. So if the first value of B is 4, so the next time is going to be 3, it's going to be 2, it's going to be 1. Now that's 4 times. When it gets to 0, I'm going to stop. That's why I put return 0. That means stop. I added A enough times, which is B times. Right? So that's how the recursion. So let's call the function and see. I'm just going to comment this one out so we can just focus on this. So if I call the function multiply 5 and 4, using these two values, so I'm supposed to have 20, right? But we are using a recursive function. If you run the program, if you don't get 20, then we got something wrong. As you can see, sure enough, now maybe it was by accident. Let's try two different numbers. So maybe 7 and 6. Everybody knows that 7 times 6 is 42, but we are using recursion, which means we are adding 7, as you can see, A, plus, and then we are using 6 as a counter. So that's why we subtract 1. 6 minus 1, 5, minus 1, 4, minus 1, 3, 2, 1. That's enough. That's why we add, once B becomes 0, stop. Because we added 7 enough times, which is 6 times. And let's run the program, we should have 42. And sure enough. Now we can do the same thing for the power, right? So let's say I want to calculate the power of 2. I want to calculate, let's say, 2 to the 5th, or to the power of 5. So we can use the power, but we can use, just like what we did here, we can keep multiplying 2 times itself 5 times. So it's pretty much the same thing as the one we just had. That's why I'm just going to copy this, then make the necessary changes. Instead of adding, we are multiplying. So I'm going to copy this, copy it, and then paste it in here. I'm going to comment this one out. So if, I'm sorry, I have to do it with the other function. So I'm going to call it power or pow. So A is my base and B is my exponent. So here I'm going to be very careful. I'm not going to put 0 because if I multiply everything by 0, so I'm going to say I'm going to put 1 because when you multiply by 1, nothing will happen. And then change plus to multiply. And then the same thing. Pow, I'm not going to change this. Keep it the same way. So basically, I'm keep multiplying A times A times A, B times. That's why when we get to B equals 0, we stop. That means we multiplied A enough times. So now let's call the function pow and see if we get the expected answer. So pow, let's use 2 comma 5. Should be 32, right? So let's see if we're going to get 32 as output. All right, that's sure enough. All right, so now you should be, should be comfortable with the recursion. So basically, you just keep calling the function over and over a certain period of times until you get to the base case or to the stop condition. Okay. Now let's solve like a problem here. Let's say I want, for example, I want to add let's say I'm going to prompt the user to enter a number that has a certain number of digits. And using recursion, I want to count how many digits you have. So I'm going to say here, count digit. That's what I'm going to call it. It takes a number, whatever it is, and then I want, using the recursion, I know like you can solve it using the loop, while loop, for loop, whatever, but I want to use the recursion. So how can I use the recursion? So basically what I'm going to do, if I want to count, but also without changing it to string, okay, we don't want to cheat here, right? So we want to keep it as a number. So let's use an example here. Let's say we want, okay, we're not going to call it yet, but I'm just going to say what example we're going to be using. So let's say, for example, we got the number from the user. Okay, count digits 2541. So this one has 4 digits, right? 2541. So how can I do that using recursion? I know like every time I divide by 10, I get 1 digit less, right? So 2541 divided by 10, I'm going to get 254. And if I divide by 10 again, I'm going to get 25. If I divide by 10 again, I'm going to get 2. But once I divide by 10, I'm going to get 0. That means when you get 0, that's the end. What I'm going to do, as long as the number is not 0, so if num is 0, that means that's it. That's base case. Why? Because I divide by 10. Enough times, there is no more digits to process. So I'm going to put here, return, return. So if we got to 0, we are going to return 0. Else, I'm going to put return 1 because I'm counting 1 plus, and then call the function again. But here, I have to divide by 10. So I'm going to put here, divide by 10, then return. So I'm going to put here, else. So we're going to divide by 10. So that's num divide equal by 10. So the first number, well, let me put this one after that. It doesn't really make a difference. I'm sorry here. Oh, let me put it inside the bracket. Sorry. I'm going to put count digits. Oh, that's what we have. So I'm going to put num divide by 10. So 2005, okay, D should be capitalized. So I call the method, but changing the number, because if you don't change the number, you're going to get an infinite recursion. So now let's call the function here. So 200541, we should get 4, right? So let's see if we got number 4. There we go, we got 4. Maybe it was an accident. Let's change the number. let's say 3, 8, so that's 2, 4, 6. We should have 6. And we got the same thing, 6. Now, what about if I want to add them up? I want to add up these numbers, okay? I don't want to just count how many digits. I want to add them up, which is 2 plus 5 plus 4 plus 1. So I just have to make a little change, right? It's almost the same. I just have to change it. So I'm going to just copy that code, and then change it to some digits, okay? So I'm gonna go right here. I'm gonna call it some digit. So what do I need to change? So there's no much to change. So I'm gonna put num0 return 0, but I'm not gonna add 1 because I'm not counting, but I am adding every single digit, which is basically num mod 10, because 2541 mod 10, that's going to give me the first digit to the right, which is number 1. Okay, and I'm going to divide by 10. 1 is gone. Now the mod 10 would be 4. Then you divide by 10. Now 4 is gone again, so we have only 25. So mod 10 will be, and so on. So you're going to add every single digit. Okay, so and then make sure that you divide by 10, which you already have. So make sure you're calling some digit, not count digit. All right, now let's call the function and see if we're going to get 2 plus 5, 7, plus 4, 11, 12. All right, let me end the line here. So I'm going to put some digit, 2, 5, 41. We should get 12 because that's the sum of this digit. There we go. Now let me add with this, okay? If you remember, we did the binary search, right? So the binary search basically assumes that the list is sorted. So we're going to use binary search, the code of binary search, but this time using recursion. Okay. So let me delete all this stuff so we don't get confused. Delete all this stuff right here. So if you remember, binary search is the most efficient algorithm when it comes to searching, right? It assumes that the list is sorted, and then you keep dividing by 2, like the list or the array by 2, and then you focus on the middle number, okay? So if you remember, this is the normal one, okay? And then you return the location, okay? So this is binary search. If you remember, it requires the array itself, let's call it R, okay? And then we need the lowest index and the highest index, and then whatever we are looking for, let's say key or target, right? So what do we do? Of course, we need 3 variable. Okay, we already have low, high. Maybe you can add the mid. Okay. So what we're gonna say? Okay, what is the mid? By the way, is you add the low plus high, and then you divide them by 2. Okay. And then we add them up. We divide them by 2, and then we compare. We compare the middle number. So as long as the low, because as long as there are numbers process, which means as long as low is less or equal than high, that means there are numbers to process. So we're going to keep splitting the array into half until low is not less or equal, which means they overlap, which means that there are no more numbers left. So if low is less or equal than high, then we already have the mid. Okay, let's just put the mid here. I'm just going to put mid, declare it here, give it 0 maybe here. And then I'm going to put it inside the if statements because it's going to be happening many times. So I'm going to put mid is this. Now I'm going to compare if R mid, so this is mid. If R mid equals the key that we are looking for, our target, that's it, done. We're going to return mid. Okay, that's like the best or the the best case scenario. Else, we have two situations. Remember, I'm not using the recursion here. I want to just now put the old code, and then I will show you how you can use recursion for the same code. So else, and I'm going to compare. If R mid is higher than the key, that means on the right side, so we need to change the mid. Mid will be the low plus one. I'm sorry, mid plus one. Mid or the low will be mid plus one because the number is on the right side. Let's see here. If the key is higher than R mid. Okay, so if the key is on the right side, then we change the low and then we keep the high the same. Okay, else we should change the high, which is mid minus one. And then we keep doing this over and over again. Okay, if we did not find, maybe here, if the low is not less or equal than high, now for the old one, we don't have if statement, we have while loop. While low is less or equal than high, mid is this, and then we go else, and then we are going to put the return at the end. Okay. So it is return mid else, and then yeah, and then at the end we're going to put return negative one. So this is the old code. Okay. Now what about if I want to use recursion for this? So I'm going to delete this and then show you how it works. So we're going to use the if statement. We don't use the loop, but we are going to call the function itself. Okay. So what we're going to do is using the recursion, I'm going to put here if low is less or equal than high, that means there are numbers to process, right? If low is less or equal than high, then we're going to put mid equal low plus high divided by 2. Okay? Now, of course, if low is not less or equal than high, that's the end, which means there is no more numbers. We could not find it. We're going to put return negative 1. So we're going to put else. Else, return negative 1. Now we have two situations here, mid equals low plus. Okay? Two situations. We have the first situation, which means if we found what we are looking for, which means if R mid is equal to the key, then that's it, return mid, that's the end of the story. Okay, now else if, that means if we did not find the key, we have two situations. If the key is higher than R mid, that's the middle number, then that means the key is on the right side. So now here I'm going to use the recursion. I'm going to say return and then call the function again, which is binary search. The array will be the same. The low will be what? Because the key is on the right side. So we're going to change the low. Low will be mid plus 1. High will be the same and key will be the same. Okay. And then what about if it is on the left side? Else if the key is less than R mid, if it is less than yeah, R than mid, then we're going to call the function again, but binary search. R will be the same. Now, since it's on the left side, low will be the same. It's not going to change. And then the highest will be mid minus 1. And the key will be the same. All right. As you can see, it's the same code, but using binary search, because the list keeps shrinking and shrinking, split into half until either we find what we are looking for, if it matches the middle number, or there are no more numbers, we could not find it, and that's the end. I hope you find this video useful and beneficial. If you still have questions, please do not hesitate to reach out. Thank you.